Alright, here's a review video for you to help you get ready for the math test tomorrow. I've made a list of things that I think will help you as you prepare. First of all, you can go to Kaplan, to our Kaplan site. There are videos there. There's one specifically on dimensional analysis that you can review. Also, there's some practice questions and everything on there that you could do as well. I want to mention conversions. Make sure that you know your conversions. So pounds to kilograms. How many milligrams are in a gram? How many milliliters are there in a teaspoon and a tablespoon? Make sure that you know that information. Also, I want to mention zeros, and this is misplaced zeros. So you will get the problems wrong. You will get an answer incorrect if you put a zero in the wrong spot. And what I mean by this is, for example, if the answer is 0.4, it needs to be written as 0.4, so it's not mistaken as 4. If the answer is 4, then it needs to be written as 4 and not 4.0. Okay? So make sure you take note of that. Also, don't get hung up on any unnecessary information. So, for example, sometimes I will even look at the end of the problem first and see what is it they want me to know. What information is it they're asking for? So if it's how many tablets per dose, or how many milligrams per dose, or is it how many milligrams per week? Okay, once I know that information, then I can weed out any unnecessary information within the problem. Dimensional analysis. I'm going to give you a brief overview of that in just a second, how to do dimensional analysis, and I'm going to give you the topics that are going to be on the exam so you know what to study, and I'll give you some examples of those as well. Okay, oral dosing. You need to know that. So oral dosing, and what I mean here is how many milliliters of a medication will you give? How many tablets are you going to give, for the prescribed amount? IV calculations. So with IV calculations, this can mean your drip rate, like how many drips per minute of a medication, or how many milliliters per hour. And typically, I want you to get in your mind, if you see flow rate, that's generally like if it says, what's the flow rate that you'll put on your pump? It's asking milliliters per hour. Okay? Weight dosing. That's another thing that you need to make sure you review. So that means, for example, how many milligrams per kilogram of a medication are you going to give? Say the doctor orders 10 milligrams per kilogram. How much are you going to give? Calculating dose ranges. That's another topic. So that means, for example, your dose range is going to be 10 milligrams per kilogram to 20 milligrams per kilogram. So what's that range going to be? How many milligrams is that? IV infusion times. So this means how many hours is it going to take for this bag to infuse? All right. If I have a bag that's 1,000 milliliters and it needs to go at 50 milliliters per hour, how many hours is it going to take for that bag to run in? And finally, reconstitution. And reconstitution, that's like if I have, a certain amount of the medication, I have to dilute it with, some fluid, and then, how much fluid am I going to end up giving of the medicine? And I'll give you an example of that too. All right, so first, I'm going to go over dimensional analysis. All right. Now, you can use this for almost every problem that you need to solve. Okay, unless it's just simple division or multiplication, like some of these are, you can use this for every problem. So what you need to do first is you figure out, what do I need to know? All right. So let's say that the physician orders 750 milligrams of amoxicillin PO-TID. How many tablets am I going to give per dose? All right, so first of all, my needed information is not PO, TID, whatever. It's just 750 milligrams. The second piece of information I need to know there is how many milligrams are in each tablet. Now, when I set up my problem, I'm going to lead with what I want to know. So in this case, that's going to be tablets. Okay, I want to know how many tablets am I going to give. Now, in your next column in dimensional analysis, you're going to put, what do I have on hand? What kind of shape or form does my medication, fluid, whatever it is, what does it come in? And in this case, it's going to be 1 tablet has 250 milligrams. Now, why do I put one tablet on top? Because with dimensional analysis, whatever I'm looking for is what I lead with. So if I have tablets here, I need tablets here. Okay? So I've got one tablet, has 250 milligrams. Now my next tablet is what am I going to give? What's ordered? Whether it's milligrams, fluid, whatever, what is ordered. So in this case, it's 750 milligrams. I'm going to multiply these straight across. Then I'm going to divide. And I know this is real simple math here, but I'm going to end up with 3 tablets. Okay, this is your basic dimensional analysis and how you set that up. I'm going to do another one, and this is going to be for milliliters. Okay, so let's say I have Benadryl 40 milligrams IM stat for an allergic reaction. My Benadryl is supplied to me in 25 milligrams per milliliter vials. Okay, so there's my concentration. So what's the first thing I'm going to set up? If I need to know, how many milliliters am I going to give to the patient? So I'm going to give, I know I'm going to give it IM. So how many milliliters am I going to give? So the first thing I'm going to put is going to be milliliters. Then I'm going to lead with milliliters because that's what I want to know. So first column is, what do I have? I have 1 milliliter vials with 25 milligrams. All right. What am I going to give? 40 milligrams. Multiply straight across and then divide. And I've got 1.6 milliliters. Now I'm going to mention here, don't get hung up on rounding rules because we've included on each question, it tells you exactly what to round to. So round to the nearest whole number, to the nearest tenth, nearest hundredth, whatever. It's going to be on the problem. Okay, drip factors. All right, that's the next thing we're going to talk about. Drips per minute. So let's say you've got 250 milliliters of normal saline. It needs to infuse over 4 hours. Your tubing that you have available is 10 drop per ml tubing. Now, how am I going to figure that out? So first thing I'm going to set up, so I'm looking for my rate, and I want to find drops, so I'm going to do drops per minute. Okay? How many drops per minute? And it will tell you in the problem. So drops per minute. All right. What do I have available? I have 10 drop per ml tubing. What am I going to give? I'm going to give 250 milliliters of normal saline over 4 hours. Well, can I stop there? No, because I need drops per minute. Now, I forgot to mention this on the last couple problems. I'm sorry. You want to make sure, I'm going to stop for just a moment. You want to make sure that you cancel everything out and you end up with only what you want. So I want to find tablets, so I'm going to cancel everything out. So I'm only left with tablets. Here, Benadryl. Same thing. I want to find milliliters, so I cancel everything out. So I'm only left with milliliters. Now, back to this. So I'm giving 250 milliliters of normal saline over 4 hours. I've got 10 drop per ml tubing. All right. So I've already set up what I have, what's ordered. Now, I can't stop there because I need to find out drops per minute. So I've got to add my conversion factor. So I know that for every 1 hour, there's 60 minutes. Now, this same thing will hold true whether you're converting teaspoons or, tablespoons, whatever, if you just add that conversion factor at the end. Okay? So I'm going to do the same thing, multiply straight across. I'll end up with the 2500 over 240. When I multiply that out, I'm going to get like 10.416 something something. And because I'm dealing with drops here, it has to be whole numbers. So I'm going to round that to the nearest whole number, which is 10 drops per minute. All right? So that's how we do drops per minute. I'm going to hold that up there for a sec. So milliliters per hour, and this is pretty direct, pretty straightforward. If say for example, I have a 1,000 milliliter bag that I need to give over 6 hours, I'm just going to use simple division. So 1,000 divided by 6, and let's say it tells me to round it to the nearest whole number, then it'll be 167 milliliters per hour. converting pounds to kilograms. Again, this is just simple conversion. So if I have an individual that's 150 pounds, then I'm just going to divide by 2.2. And let's say that I need to round it to the nearest tenth. It'll be 68.2 kilograms. Okay. All right, so we talked about how to convert to weight. Now we're going to talk about a dose range. So let's say, and that's 250, sorry. Let's say that your order is 250 milligrams PO/TID for a patient that is 150 pounds. Your safe dose range is going to be 10 to 20 milligrams per kilogram per day. Is the dose safe? All right, so what am I going to do first? Well, I need to know how many kilograms is my patient, right? So if they weigh 150 pounds, we just figured this out, it's going to be 68.2. All right, now I need to figure out what's my dose range. All right, so if it's 10 to 20 milligrams per kilogram per day, here's my dose range. So my low end is going to be the 68.2 times 10, so 682, and that's milligrams, by the way. Okay, and then my high end is going to be 68.2 times 20, so that's going to be 1,364 milligrams. So my range is going to be safe dose per day can be 682 to 1,364. All right, so if I'm getting 250 milligrams PO/TID, TID means 3 times a day, so I'm going to multiply 250 times 3. What's that going to give me? 750. So is my dose safe? Yes, that is a safe range. Okay, so you may be asked, a couple questions like this on the exam where you'll have to figure out safe dose ranges, and it may even take it a step further where it'll say, the medication is supplied in, 100 milligrams per 10 milliliters. How many milliliters are you going to give? Okay. And then infusion times. I thought that I did that. I thought I made one for that. But infusion times, that's going to be, like if you've got, say, 1,000 milliliters and it's infusing at 50 milliliters per hour. How many hours is it going to take for that medication to infuse? Okay, and then finally, reconstitution. Okay, so let's say I've got 10 milligrams of Solu-Medrol, okay, and I'm going to dilute that with 3 milliliters of normal saline. So this is ultimately my concentration, 10 milligrams and 3 milliliters. All right, but let's say that I need to give 5 milligrams. All right, so how am I going to set my problem up? Well, first of all, we're dealing with milliliters, okay? So I need to know how many milliliters of the medication I'm going to give. So that's what I'm going to lead with, milliliters. What do I have on hand? 3 milliliters of solution that has 10 milligrams of medication. What am I going to give? 5 milligrams. So I can cancel out my milligrams, okay? Multiply straight across. 15 over 10, 15 divided by 10, that's going to give me 1.5 milliliters. Okay? So that's how we're going to deal with reconstitution. Now, I hope that this will help you. I hope that this will help you get started. I'm almost out of time on the video. If you have questions, please just email me. I will be available this evening till maybe around 10 o'clock. And those will also be my normal virtual hours. Moving on is 8 to 10 on Sunday nights. So just let me know. I really think that you guys will be fine. There's 25 questions on the test. And very, very straightforward. So we can even do a little review in the morning too if we need to. So again, let me know if you have any questions. I hope you all have a good night, and I will see you tomorrow.